In this section, we will learn ways that we can describe characteristics of the graph of polar functions that we talked about in 314. Given the polar function r is equal to f of theta, we know r is going to represent the signed radius. Again, we know it's called the sign radius because r could be positive, it could also be negative. So as we trace the graph of a polar function, we're normally interested in whether the graph of r is getting closer to the origin or further away from the origin. So a couple things to keep in mind. If these are matching, if your graph is both positive and increasing, or the graph is both negative and decreasing, you should know that your graph's going to be, the distance between kind of your radius and the origin is going to be getting bigger. It's going to be increasing, but these kind of have to match, same. So if they're opposite, if one is positive, like say my graph is positive, but the rate of change is decreasing, it's going down. Again, that means the distance between r and the origin is going to be going down. Same if this is backwards, if the function's negative, but it's also increasing. So again, if they're different, if they're opposites, then I know the distance is going to be decreasing. If they're the same, then I know the distance is going to be kind of increasing. Now again, they give us this graph of 1 plus 2 sine of x between 0 and 2 pi. They want us to kind of describe what happens. And again, normally it's going to help if they give us kind of, or if we draw a rectangular graph for this. Again, this plus 1 means our new midline starts at 1. That's kind of our new middle line. Makes it go up by 1. If you kind of remember, that's what this plus 1 does. Again, the amplitude is 2. That's why I go up to 3. I go down 2, down to negative 1. Again, sine starts at 0. It goes up to the maximum. Oops. Hits my 0 at pi. Goes down to my minimum, and then again ends at the midline when I get back here. So as I kind of go around my circle, I'm going to start at 0, and again, all of this is positive until I get to pi over 2. That's my first quadrant. So kind of when I start at 0 at point A, think about this as kind of like point A. I'm going to be positive. It's going to keep going up until I get to point B. This would be point B when it's 3 away. Again, this is 1, 2, 3 away when I'm up at pi over 2. Kind of the idea. So that first part of my graph from 0 to pi over 2 is kind of talking about this curve going from A to B. Then this is going to be decreasing. It's getting smaller, so it's going to get closer and closer to the origin until I get to right here. And they don't call this a point, but pretty much until I get to pi, right? This is pi. So again, when I get to pi, that's kind of when it's stopping there. It's kind of getting closer, though. It's going down. It's decreasing. It's positive and decreasing. It's getting closer to the origin. Now there's this weird little part where it's still kind of positive and it's still decreasing. So that's going to be this little kind of bottom part here. And then as I kind of keep going around, this starts to become negative now. It's going to go opposite. So that kind of goes, this would be technically point D. When it's going backwards at negative 1 at 3 pi over 2, this would be like 3 pi over 2. So again, it's going backwards by 1. So instead of going forwards by 1, which would be like right here, it's going backwards. That's why it's going to point D. This would technically be point C. So when I'm hitting at 0, and then I'm kind of going to keep going. Again, there's this little part here. That's kind of this little part. And then at the very end, it kind of starts to be positive again. That's this little kind of bottom part at the end. And again, we end back at point A again at the very beginning at 2 pi after we go all the way around. So again, I know my graph is positive and increasing between points A to B. Actually, I shouldn't call it A to B. I'm going to call it 0 to pi over 2. It's also positive and increasing between 11 pi over 6 to 2 pi. It's positive and decreasing kind of here. So from pi over 2 to 7 pi over 6. That's when it starts to become negative. It's negative and increasing kind of between 3 pi over 2 to 11 pi over 6. And then it's negative and decreasing between C and D at 7 pi over 6 to 3 pi over 2. So again, down here, they also kind of give you a little table to show you, again, from A to B, from B to C, from C to D, from D to C, from C to A, kind of all the different steps, kind of as we go from A to B, from B to C, from C to D, and then from C to A. Kind of tell you when they're all positive or negative, and then increasing or decreasing. And then if the distance, again, if these are both positive, this is increasing. This is positive and decreasing, so this is decreasing. These are both kind of negative, so this is increasing. These are opposites. One's negative and one's increasing, so this is decreasing. These are both positive, so this is increasing. The things to keep in mind. Now again, they're only going to give you multiple choice questions on this, so you'll never have to like write this stuff out or do any of this, but they might ask about this kinds of stuff. So again, it's often helpful to sketch a graph of the given function in rectangular coordinates. So again, that's drawing like one of these graphs and kind of trying to think about what's kind of happening as we kind of describe the behavior. So we're going to go through examples 2 and 3 today, and then we'll probably finish the rest on Monday. So if we look at example 2, it says, consider the graph of the polar function r is equal to f of theta, where f is equal to 2 minus 4 cosine theta in the polar coordinate system between 0 and 2 pi. Which of the following statements is true about the distance between the point with the polar function or polar coordinates f of theta and the origin? So let's draw a graph. Here's 0. And we have to be careful. We're going up by 2 because of this 2. So I'm going to go up to 1, 2. Make this like my new line at 2. My amplitude is 4, so it's going to go up to 1, 2, 3, 4, up to 6. It's going to go down 1, 2, 3, 4, down to negative 2. This is a negative cosine. I would almost rewrite this like minus 4 cosine of theta plus 2. So you can see that this is positive, this is negative. So since it's negative 4, I'm starting at the bottom. Let's do this. 1, 2, 4. Again, this is 2 pi. Half of 2 pi is pi. Half of pi is pi over 2. And again, these are just like our coordinates in the unit circle. 2 pi over 2 pi, 3 pi over 2, 2 pi. Start here, go to the middle, go to the top, go to the middle, and at the bottom. Should end up looking something like this. And I will tell you it's crossing here. This is where it's going to cross at pi over 3. This is where it's going to cross at 5 pi over 3, kind of over here. So you should see here they're going to say between pi and 5 pi over 3, here's pi and 5 pi over 3. I'm talking about this part. This is decreasing. Actually, I shouldn't say this, but even over here, it should be this. This is actually, should be positive, but this should be decreasing. Let's change this one. And so again, this should be, I shouldn't have erased that, but this should be decreasing too. So it's not A. Again, these are opposites, positive, and it should be decreasing, going down. If I look between 5 pi over 3 to 2 pi, that's kind of this little ending part. It is negative, but it's also decreasing. This should say decreasing. So it's not B. Again, between pi and 5 pi over 3, it's the same one we looked at for the first one. It should say decreasing, positive, decreasing. So kind of like what I wrote for A. So should be C, I think. And then kind of same thing for D. This should actually say increasing, since this is going to be negative and decreasing. If they're both kind of negative and decreasing, this should be increasing, so it won't be D. So answer should be C. And again, kind of drawing this graph and being able to see this, I think, helps a lot. So being able to see kind of, is it going up, is it going down? That's what you kind of want to see. Is it positive? Again, if it's over this line at 0, that makes it positive or negative. If it's going up, it's increasing. If it's going down, it's decreasing. So kind of what you're thinking when you're looking at it. Is it positive or negative? Is it increasing or decreasing? So that's example 2. And then looking at example 4, or example 3, sorry. Graph of f is equal to 3 sine of 2x, where 0 is in between, or x is between 0 and 3 pi over 2. Shown in the rectangular coordinate system, if the polar function f of theta is equal to 3 sine of 2 theta is graphed in the polar system between 0 and 3 pi over 2, on which of the following intervals is the distance between the point with the polar function and the origin decreasing? So again, they kind of have to be opposites. So if I'm going to look at these intervals, this is from 0 to pi over 4. 0 to pi over 4 is both positive, and it's going up. It's increasing. Since these are both positive, then it should be increasing. So it's not A. If I look between pi over 2 and 3 pi over 4, here's pi over 2 to 3 pi over 4. That's negative and decreasing. Negative because it's under my x-axis. Still decreasing because it's going down. Again, these both match. Same. Negative and decreasing means this is increasing the distance. So it's not B. 3 pi over 4 to pi is this little section. This is negative and increasing. Since these are opposite, it's going to be that one. This would be decreasing, so I think it's going to be C. And then just to look, if I look between pi and 3 pi over 4, kind of like A, it's positive and increasing. And again, because they're both positive, I know the distance is going to be increasing. So the only one that's opposite and decreasing would be C. We're going to stop there, I think, for today. So finish the rest of this on Monday. So if you guys want it, I do have the Unit 3 multiple choice review questions. You guys want those now? Okay.